Welcome back to part 3 of our videos on areas and distances. In the previous video, we were trying to find the exact area underneath the curve y equals x squared between x equals 0 and x equals 1. And we don't really have the tools yet to be able to find the exact area, so we've been approximating the areas using right Riemann sums and left Riemann sums. And so I'm showing the calculations here. We got R4 is equal to that decimal and L4 is equal to that other decimal. And we don't quite know what the exact area S is, so we gave it a question mark. But we know that the exact area is between R4 and L4. So what are we going to do to try to make our approximations closer to the exact area underneath the curve? Well, we can make our answers more accurate by using smaller rectangles, and we still want to use the heights of these rectangles by plugging them into the function. So what we're going to do is we're going to make our rectangles skinnier, and by adding or making them more skinnier, we're going to be able to fit more rectangles into our interval. So here we divided our interval into 4 subintervals. Let's divide it into more of them. So what if we divided our interval into 8 pieces, or 8 subintervals? The width of the rectangles would be what? Well, we know that we're looking between 0 and 1, and we're cutting them up into 8 equal subintervals. So the entire length of that original interval is 1, and if I'm cutting them up evenly into 8 subintervals, then the width of each rectangle would be 1/8. So in the picture on the left, if I were to add the areas of each of these skinnier rectangles, and if I were to add them all together, that sum would give me the value for L sub 8, which is the estimation for the area under the curve using left endpoints for our subintervals and 8 subintervals. So let's go ahead and start to calculate that. L sub 8 is going to equal, once again, each of our rectangles has a width of 1/8, so I'm just going to factor that out, and inside of my brackets, I want to add up all of the heights of my rectangles. And so that's going to be f of 0 plus f of 1, not 1, f of 1/8 plus f of 2/8 plus dot 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 plus f of 7/8. And then notice here, so we have 2/8 here, 3/8 dot dot dot. 1 is equal to 8/8, and then our x value before that would be 7/8, and notice that 7/8 is the last height that we're using to determine the height of one of our rectangles, so I actually don't want to add anything else, and f of 7/8 is going to be my last height. Now, I don't want to have to calculate each of those things, because what's going to end up happening is we need to make our rectangles even skinnier after this example, so I'm kind of looking for a shortcut instead of having to evaluate each of these things individually, because that's going to be a lot of calculation on our part. So is there a way that we could rewrite this whole thing that I have inside of my brackets? Well, it's something that we learned previously. We learned about summations. So I'm just going to rewrite my 1/8, and then the thing inside the brackets, I can actually rewrite that using a summation. Pause the video to see if you can figure out what the indices will be and what goes inside of our summation. So our lower index is going to start at I equals 0, and then our upper index is going to end at I equals 7. And if you notice the pattern, the things that we're adding together are f of I over 8. And so that's what we are looking at. And we can rewrite this summation, right? Because we have 1/8, and f of I over 8 is the same thing as I over 8 quantity squared. And if I simplify that, that's going to be the same thing as I squared over 8 squared is 64. And then if I wanted to, I could factor out 1 over 64. So I'd have 1 over 8 times 64 is 512. And then times the summation from I equals 0 to I equals 7 of I squared. Now, there's a few different ways we can proceed from here. In the very first section that we learned about, we learned a theorem about how to expand the summation of I squared from 0 or from 1 to n. If I plugged in 0, 0 squared is 0, so I could really just replace this with 1 if I wanted to, and those would be equivalent since, again, 0 squared is 0. And we learned about that theorem, and so we could plug this into that formula. Another way that we could go about doing this is our graphing calculators can actually accomplish summations. So let's pull out our graphing calculators really quickly. All right, so in my calculator, I want to enter in the fraction 1 over 512. So I'm going to press alpha and then this button in the top left corner. And if I choose this first option here, that's what ends up giving me a fraction bar. So my numerator is 1, and then my denominator is 512. All right, so we have our fraction here, 1 over 512, and now we want to go ahead and multiply that by our summation. So I'm going to go over and click Math, and then I'm going to scroll down this list, and it's option 0. It comes after int, so I have my summation here. I'm going to press Enter, and here our index is I equals 1. We don't have the I button, so I'm going to click this button here to give me x, and it just represents a variable, so that's fine. And our lower index, you could either have it start at 0 or 1. That's not always the case, but remember, 0 squared is 0, so if I add 0 to my sum, it's not going to affect it. And then my upper index is 7. And then the thing that we're summing is our variable squared. So I'm going to click X, and then I'm going to hit my squared button, and then from here, will press Enter. And that gives me 35 over 128. We did our previous calculations for L4 and R4, and we got decimals, so it'd probably be helpful if I turn this into a decimal. I'm going to do that by clicking Math, and then option number 2. If I press Enter on that, that will convert that into a decimal. I just need to press Enter. So that gives us our value for L8. All right, so we calculated L8. Let's go ahead and calculate R8 now. So R8 is equal to, each width is 1/8, and then I want to add up all of the heights. So notice that the height of my very first rectangle is dependent on 1/8, and then the heights continue, and my last height is 1, which is the same thing as 8 over 8. So we have f of 1/8 plus f of 2/8 plus ... and then our last one is f of 8 over 8, or just 1, whatever you prefer. And then from here, we can do the same thing that we did before and rewrite that as a summation. So this is equal to 1 over 512 times the summation from I equals 1, and then we're stopping at 8, of I squared. So if I throw that into my calculator, like we did previously, so I went ahead and I plugged in the same thing into my calculator. It's just now our lower index starts at 1 and our upper index ends at 8. And so if you do that calculation, we end up getting this decimal here. All right, so that concludes this video. We've found the two approximations that we were looking for, L sub 8 and R sub 8, and notice that these numbers are getting closer together.